Okay, so we're going to prove that for any set B in a family A of sets, that the intersection of these sets, right, is always a subset of any set in the family, right? So let's give a particular example. So let um, A, right, this family be the set containing A1, A2, and A3, right? So let this family contain the sets A1, A2, and A3. So let's go ahead and draw a picture of A1, A2, and A3. So A1, A2, and A3. What this statement is saying is that any of these sets, right? Any of these sets in this family, right? The intersection is a subset of any of those sets, right? So the intersection of all three of these, right, is going to be right here, right? That's the intersection. And notice that intersection is a subset of A1, that intersection is a subset of A2, and that intersection is a subset of A3. Okay, so this intersection is a subset of every single one of these sets in the family. So that's basically what this statement is saying. Okay, so let's go ahead and do the proof for this. So proof. First, we're going to let A, right, be a family of sets. Okay, and B be an element of this family, right? So we're going to suppose X is an element of this intersection, right? This intersection right here. Intersection A contained in this family for every set A contained in the family of the A's. Okay, so we're going to let X be an element of that. So what this means, right, if X is an element of the intersection, this means that X is an element of A, right, for all um, for all A's contained in the family, right? So we know X is an element of every single one of these sets, right? That's what this is saying. If X is in the intersection, that means X is an element of every single one of them, right? Okay. So clearly, if X is an element of all of them, right? This means that X is an element of B because B is just one of the sets, right? We established that B was just one of the sets in the family, right? So if X is in all of the sets in the family, that means X is an element of B, right? Of course, we can write since B is an element of the family, right? So we have that for every X is an element of the intersection of the A's contained in the family of A, implies that X is an element of B, right? So of course, this means that the intersection of these sets in the family, right, is a subset of B. And that is the proof.